This video is on Maclaurin series by repeated implicit differentiation. Example 7. The variable x and y are related by dy dx equals to 2xy minus 1 and y equals to 1 and x equals 0. The questions want us to show that at x equals 0, the 3y dx cubed equals to negative 4 and the 4y dx to the power 4 equals 12. So how do we show it's exactly the same as what we did for example 5 and 6. So now we are given that dy dx equals 2xy minus 1. Differentiating with respect to x, we'll arrive at the 2y dx squared equals to 2x dy dx plus 2y. The technique here is similar to the earlier example 5 and 6. So details will not be given here. So once we arrive at equation 1, which is the 2y dx squared equivalent to 2x dy dx plus 2y, we're going to differentiate this equation implicitly again, and we'll arrive at equation 2. So after finding equation 2, I still have to differentiate this equation implicitly with respect to x, so that I'll arrive at the 4y dx to the power 4 equivalent to this sum here. Right, the reason behind is because we are required to actually show that x equals 0, while the 3y dx cubed is equal to negative 4 and the 4y dx 4 is equal to 12. It's given that when x is 0, y is 1. So subsequently we can actually go and find out what is the value of dy dx. dy dx is exactly 2xy minus 1, so substituting when x is 0 and y is 1, we'll arrive at negative 1. As for the 2y dx squared, we have 2x dy dx plus 2y. Substituting x equals to 0, y equals to 1, and dy dx equals to negative 1, I'll arrive at this as my answer. The 2y dx squared is 2. So similarly, to find the 3y dx cubed, we're going to substitute the value of x, dy dx, and the 2y dx squared. We'll eventually get the 3y dx cubed equals to negative 4. And last but not least, the same process, we'll find that the 4y dx 4 equals to 12. Right, after finding the values of the 3y dx cubed and the 4y dx to the power 4 and x equals to 0, the next part of the question asks us to find the Maclaurin series for y up to and including the term in x to the power 4. So by Maclaurin's expansion, we know that fx can be rewritten in this form. And since when x equals 0, y equals to 1, dy dx equals to negative 1, the 2y dx squared equals to 2, the 3y dx cubed equals to negative 4, and last but not least, the 4y dx to the power 4 equals to 12, we are able to sub in all the values to every single term here. f0 is the y value, f prime 0 is the dy dx value, f double prime 0 is the d2y dx square value, f triple prime 0 is the d3y dx cube value, and not forgetting the term in x to the power of 4. Whereby this f40 is the value of d4y dx4. So after substituting all these values in, this is the Maclaurin's expansion for y. Alright, for the last part of the question, it says this. Hence, find an approximation to the value of y at x equals to 0.1, giving your answer correct to 4 decimal places. So earlier we have written y in this form. So when x equals to 0.1, we're going to sub this value to our right hand side. And eventually, we will have y is approximately this value, which is calculated to this value 0.9094.